JAX, the leader in food-grade lubrication technology, presents an introduction to lubrication basics. In this module, we will discuss reasons why we use lubricants, the function of lubrication in your plant, and fundamentals for choosing the right lubrication for the job. So why do we use lubricants? Some of the primary functions of lubricants are to reduce friction and to dissipate heat. You'll find friction whenever two surfaces rub together. Even if the surfaces look flush and smooth, similar to what you would find on bearings and gears, you would still have tiny asperities causing friction. When oil is added between the two pieces of metal, you can see that less force is needed to move the block, and there is less resistance. The oil has created a barrier between the wear points of the metal, reducing the friction. Very little wear is occurring, and very little heat is being generated. It also requires less force or amperage draw to move. Oil does more than reduce friction and dissipate heat. Lubricants also help to prevent contaminants from depositing on the surface, so they reduce buildup or sludge. The lubricant washes away the contaminant to a filter where the material can be removed. As shown in this salt fog corrosion test, lubricants also help to protect against rust and corrosion through chemical additives. Viscosity is the most important characteristic of any lubricant. Basically, thicker oil is higher in viscosity, and thinner oil is lower in viscosity. If an oil is too thin, it will squeeze out, resulting in increased metal-to-metal contact, increasing wear, friction, and temperature. But if an oil is too thick, it will increase internal fluid friction and temperature, reducing the useful life of both the fluid and equipment. Viscosity is measured in the laboratory with a viscometer. It is typically measured at two constant temperatures, 40 degrees Celsius or 100 degrees Celsius. So how do you know what viscosity is right for your application? For high-temperature applications, you would need a higher viscosity lubricant. For higher load applications, you would also need a higher viscosity oil. For higher speeds, you would need thinner oil, a lower viscosity lubricant. And for lower temperature applications, you'll also need a lower viscosity oil. The viscosity index, or VI, indicates how a lubricant's viscosity changes with variation in temperature. A high viscosity index indicates the oil will have minimal viscosity change with extreme temperature variation. A low viscosity index indicates the oil's viscosity will have dramatic viscosity changes with extreme temperature variation. So it's very important to consider viscosity index, or VI, for applications with extreme temperatures. It is important to know the pour point of a lubricant. This is the lowest temperature at which the lubricant will flow. This is particularly important if you operate equipment in extreme cold. Once a lubricant reaches its pour point, it won't flow under its own weight. Do you know the difference between grease and oil? Oil is a liquid. The two most common types of oils are conventional or mineral oils and synthetic oils. A lubricating grease is a solid or semi-solid lubricant consisting of a thickening agent in a liquid lubricant. So how do you know when to use a grease versus an oil? Grease is generally used in applications that can only be lubricated infrequently and where a lubricating oil would not stay in place. They also act as sealants to prevent ingress of water and incompressible materials. Lubricating equipment is easy if you have the right lubricant in the right place at the right time and in the right amount.